something that pops up around all of maths is surds. And surds are basically numbers with roots over them. Now, there are rules for multiplying and dividing surds and adding and subtracting surds, right? And before we can do anything else with surds, we need to realize all of these. I'll just go through them quite quickly to begin with. So basically, when you times two surds together, you can actually put the surds together. So root a times root b is equal to root ab. You can put them in the same surd, and you can do the opposite as well. If you have two numbers multiplied together within a surd, you can split them up. And the same works with division. Now, but if you multiply the same surd together, you can think of it as being root a squared, because you're multiplying it by itself. And the square root and the square cancel out because they're inverses of each other. So you just get a out. So when you multiply a surd by itself, you get the thing inside the surd by itself. Remember, a can be any number. That's just a placeholder. Okay, so when you're adding or subtracting, you can think, if you're adding the same surd together or subtracting the same surd, you just, if you have 1 root a plus 1 root a, you'll get 2 root a. If you have 3 root a minus 1 root a, you'll have 2 root a. However, you can't add different surds together which have different things inside of the root. You can't add them, so you can't do anything more with that. And the same goes for things when you want to add a surd to a non-surd term, you can't do it. You can't do anything with that. Okay, so if it's hard remembering all of these rules, there's a good link you can make between surds and variables that we see in algebra. So if we make root a equal to x and root b equal to y, we can see that we can multiply x and y together and we can divide x and y together, just like with surds. And obviously if you times that together, you'll get x squared. But what is interesting is when we get to the addition and subtraction rules. If we add the same variable together, we'll get 2x, just like if we add the same surd together, we get 2 root a. And the same goes for subtraction. But remember, we can't add x to y because they're different variables. We also can't add a number to x. So what you can do is, if you're ever unsure, like if you want to do root a plus root b, say, okay, can I add two different variables together? If the answer is no, then you can't add the surds together either. But so long as you can learn these rules, it's okay. You don't have to make this link between algebra. Okay, so now that we know the rules for the surds, we can do an example. Right. So, for example, you might get something like this. Find root 10 plus 3 times root 10 minus root 3. Like that. And now, what we can do is, surds are just like numbers. Well, they are numbers, but you can deal with them like any other thing you have in brackets. Now, the thing is, we can't simplify any of these, because remember, you can't add two surds together, and you also can't add a surd to a number. So we can't simplify this any further. But what we can do is expand the bracket. So we get, if we do the first, we get root 10 times root 10 plus we can do the outers. So root 10 times minus root 3, like that. Because we have the negative, you need to remember that. And then we can do the inners, so we get 3 times root 10. And then we get the last, which is 3 times minus root 3. So we've expanded it just like we would with a normal bracket. And now what we can do is we can figure out these individual brackets from the rules. So if we have root 10 times root 10, well, remember when you multiply a surd by itself, you just get the thing inside the surd. So we'll just get 10. Okay, here, in fact, this will be a minus because we're multiplying a negative by a non-negative. This time, remember we can use this rule here when you're multiplying two different surds. You get the surd, you can put it all under a surd. So we can get 3 times 10, so 30 under this surd. And then, here, well, if we're timesing 3 by root 10, we just get 3 root 10 because there are 3 root 10s. And then, finally, we get this, which again, 3 times minus root 3 will be minus 3 root 3. Now we can say, can we simplify this any further? And in fact, we can't, because obviously all of these are either a number or have a different surd. So we have 30, 10, and 3 in our surds, and none of them are the same. So that is our final answer. Okay, now let's look at simplifying surds. So we can simplify surds. Right. So let's consider if we have to simplify root 28. Right, so what we can do is, if we follow this process, we can simplify it. First off, let's split 28 into 4 times 7. And then, what we can do is, because of our rule here, where root AB equals root A times root B, we can split these up. So we get root 4 times root 7. And because we know what root 4 is, we know root 4 is 2. You can write it as 2 root 7. And this is the simplified form of 28. But you might be wondering, how do we find this number? How do we find why did I split it up into 4 and 7 and not say 2 and 14? Well, when we simplify a surd, we have to split it up into a square factor. Usually it's biggest. So let's think about our square numbers here. So we have 4, 9, we're not going to count 1, but the rest. So these are up to 100, and obviously they carry out. And what we want to do is, let's say we have 72 now, root 72. We want to find its biggest, square factor. So we can, first off, we know that its factors have got to be below 81 because 72 is less than 81. So let's work our way through and see what divides into root 72. Well, 64 doesn't, 49 doesn't, but 36 does. In fact, so does 4. Right? And so does 9. So we have these 3 factors that go into 72. But remember, we want the biggest square factor. So we should go for 36. So let's split it up into 36 times 2, because that's how you get to 72. And again, we can split up these surds, and then we can square root this to get 6 root 2. Let's see what would have happened if we chose 4, for example. Or 9, let's say. If we chose 9, we get 9 times 8. This is just another way of doing it. Okay, again we could split it up, and then we get 3 root 8. But what you've got to remember is this is not in its simplest form because we didn't choose the biggest square factor. 8 can be simplified further. So let's see what 3 root 8 simplifies to. So root 8, that 4 goes into 8. So we can write it by 4 times 2. We get 4 times root 4 times root 2. And then we get 3 times 2 because we've square rooted the 4 times root 2. We get 6 root 2. So we do get the correct answer, but with more steps because we have to simplify twice. So if you're ever unsure if what you're choosing is the biggest square factor, when you get your answer, make sure you check to see if it's still in its simplest form. Okay, now let's talk about rationalization. So this is the process in which when you have something like this, 6 over root 2, we want to put the surd on top. That's what we want to do. So how do we do this? Well, what we can do is, in this case, we can actually multiply by the denominator. So, and we also put the denominator on top. Okay, and then what will we get? Well, we have 6 times root 2, which is 6 root 2. And root 2 times root 2, well, it's the same thing in the root, so we just get 2. And obviously we can cancel this out in the fraction to get 3 root 2, like that. So how does this work? Well, you need to remember that this 3 root 2 is equal to this. We're not actually changing anything. And that's because when you divide anything by itself, you get 1. So root 2 over root 2 is equal to 1. So we're just multiplying this by 1 just to put this surd here on the numerator. So that's what rationalizing is. It doesn't change the number, but it puts the surd on top. Okay, let's think about another example. So what would happen if we had something like 5 over 3 root 2? Now see, we don't just have a surd down here, we also have a constant, a number. Well, actually, the process is the exact same. It doesn't matter if we're multiplying by anything else. We can still multiply by root 2 over root 2. Just multiply by the denominator. And that'll give us, well, we'll get 5 root 2 on the top. And we'll get root 2 times root 2, which is 2. But remember, we're multiplying by the 3, so we get 6. And that's its simplest form. Okay. Well, what we can do now is we can also rationalize more complex fractions. How about something like this? Right. So now remember we can't multiply by root 3 now because we're adding it to a number. Before, we were multiplying it by a number, we can still just multiply by root 2. But now we're adding it to a number. So what we need to do is we need to multiply it by the denominator again, but by the contrapositive. And the contrapositive is the same as the denominator, but the plus here turns to a minus. Or if it was a minus, it would turn into a plus. It basically changes sign, this middle bit, right? Contrapositive. And the reason we do that is because it nicely cancels out. So if I write this like this, because we multiply the top two together, multiply bottom two together like so. Okay. And these will cancel out, and we'll see. So now we can expand this top bracket here to get 28 minus 7 root 3. And we can, then we can also deal with the bottom bit. So if we multiply the first, we get 16. And then the inners will be plus 4 root 3. The outers will be minus 4 root 3. And the last, because they're both root 3, it'll be, but there's also a negative, so it's minus 3, like that. But now you can see that the surd terms cancel each other out. So, what we can do is we can write it without the surds on the bottom, and 16 minus 3 is just 13. And there you go. And remember, we're still only dividing by 1 because 4 minus root 3 over 4 minus root 3 is equal to 1. Alright, have a go at these exercises. This last one's quite difficult, so have a go at that if you can.